Okay, good morning, everyone. Today I will give some introduction on the anomaly detection in infrequently occurred patterns. I'm Dong from currently I'm a principal architect from Baidu. Sorry. Before Baidu, I worked for the Bell Labs and Google for about 7 years at each company, respectively. Okay, some background. Actually, I gave a talk in last December in the LISA in the Boston. That talk gave a high-level description on how we do the intelligence anomaly detection in Baidu's heterogeneously internet services. And after the talk, lots of people ask me, so what's the details and how to do the what is the algorithm and what is the data come from and so on. So this is why we give a talk here. So today I will give a detailed explanation to a case mentioned in that talk. So that means we should come back to the title. So in infrequently occurred patterns. Today I will take the holiday as the example. So we all know holiday is just a typical infrequently traffic patterns. So this is agent. Firstly, I will give a brief introduction to Baidu, and then go to our main topic. So what is the problem, and what is our idea, what's the solution look like, and finally give the results. Okay, so give some introduction to Baidu. So Baidu is actually a Nasdaq listed company, and we are often called the Chinese Google. So the main service of Baidu is search. Besides the general search, we have lots of vertical search, such as image search, video, and real-time news. Also, other than search, we also provide other kind of the internet services in China market. For example, we have the location-based services. Baidu Map is actually one of the most popular map services in China. And we also have the social knowledge services. In Chinese, we call it 贴吧 and 知道. So which means the forum-like services and question-answer services. We also have the O2O services, online to offline services. Which just means to connect the online user to some offline services, such as a restaurant, the supermarket, or buying some ticket. And Baidu also provides finance and payment service in China. We have the Baidu Wallet. Baidu is also one of the toppest cloud computing provider in China. So we have the Baidu Cloud. So totally, all kinds of services provided by Baidu covers more than 1 billion users in the world for now. Okay, let's go to the main topic of this talk. So anomaly detection. So what is anomaly detection? So I think the most of us in this room are SREs, so we have the common sense on this topic. So we launch services, internet services, and we must build or set up some monitor system to keep the eyes on if the services is healthy. So the monitor system will generate a sequence of the data with the time and forms a time sequence. So in this picture, the blue lines means the real value of the some services. And there's other two lines. One is original and one is green. So that means some expected values, which means if the service is healthy, the traffic should like the other two lines, or either the green line or orange lines. So difference between them is different generate algorithms of the expected values. We have lots of algorithm to generate the exact value. For example, the simplest one, maybe we just use yesterday's value as today's expected value, or we can use the average of the last week's value as the expected value. So that is pictures looks like. After all this data are ready, we will keep our eyes on the gaps between the expected value and the real value. When the gaps suddenly becomes large, so we will know. So some bad things happens. The on-call guess will be busy. So this is anomaly detection in theory. This sounds like not a very difficult problem, right? However, let's just step out any textbook, also go to and come to the reality. This picture is actually copied from real service of the Baidu. The time is tricky. The time is around the Spring Festival. Spring Festival is actually the most important festival in China, just like the Christmas or New Year's in United States. People always have the long vacation or long holidays. So the traffic becomes very abnormal. So you can see the gap between the real value and the expected value becomes pretty large. So there's two kinds of result. If we do nothing, and we do not adjust the threshold or do not adjust the algorithm to generate the expected value, then the on-call guest will be bothered by the whole day's alert. That definitely ruin his holidays. And another way, the second way is a common way we used before is just adjust the threshold. Typically increase the threshold to just pretend anything is normal. But the risk of this method is during the holiday, if really some bad things happens, the increased threshold will hidden this and will miss the bad things. So in such kind of situation, either we will get lots of the missed alarm or we will get lots of the false alarm. Both of those are not our expected. So how to resolve this problem? Our idea is to try to adjust the expected value. This picture shows some field ideas we tried before the real solution works. So we tried the first tool is the media compensation and the timing compensation. It's just the two variants of the armor model. The armor model, which is one of the classical statistic-based model, and we also use the hot winter. It's it's called the double exponential smoothing model. So it's another kind of the statistic-based model. We even use the back propagation to try to get the more exact values. The pictures in the right side show some result. We can see we have some progress, but overall, all this statistic or traditional statistic-based method don't resolve our problem. So after that, our idea is can we try some data mining method, or try some just bypass the traditional statistic-based method. Okay. So after we decided to try some data mining method, we just see there's a lot of difficulty for us. So I listed two main difficulties here. Back to the topic of this talk. So we are trying to do some anomaly detection in the infrequently occurred patterns. So the infrequency means there's no enough data to do training, right? So this is the first difficulties. We have no enough data. And the second difficulty is some China-specific problems. In China, so most of holidays are based on Chinese calendar, traditional Chinese calendar. So the result is the holiday date are not fixed. I have some example here. So I list three main holidays in China: the Spring Festival I just explained, and Dragon Boat and Mid-Autumn. This is the major holidays in China, and I listed their date in the last 3 years. You can see in each year they have the different dates. So what's the influence on such kind of non-fixed date? That means we even cannot use the seasonality of the time sequence to calculate some data. So this is another difficulties. So how to get data? So this is the first thing we need to resolve. Our idea is how about try to find some dates which are not holiday, but they have the similar traffic patterns with holiday. So our method is to do some, first thing is to do some clustering. Clustering on what? Clustering on CDF of every day's traffic curve, use k-means. So in the bottom, we have some result in by the different case. In the picture, say the different color means different class result. Based on our intuitive feeling, so I think the k equals 3 may be the best result. It's just clear borders between different cluster. So I can give some quantitative explanation on this, why this selection is best. So we do clustering. Clustering on the data covers 310 days from the March 1st, 2015 to the January 4th to the 2016. So covers 2 years, almost in the 1 year. Actually, every date in a year have its natural attribute. I list in the left columns. See, if the date is a working day, if the date is Saturday, if the date is Sunday, or if the date is festival, holidays. And the final column, row is if the date is special days. The special days means these days are actually not the official holidays, but they have the traffic pattern in these days are significantly different with the normal days. A typical example in China is November 11. So November 11 is currently called the China's Black Friday. So the people will rush out to not really rush out to the online market and purchase lots of things. So the traffic will become significantly different. So we call it special days. So from this result, we can say basically the k equals 3. When k equals 3, the clustering result is pretty reasonable. Since all the working days are clustered into the one class, and major Saturdays and some of the Sundays are clustered into one category, and all the other days are divided into the final categories. So after have such kind of the result, we actually can construct a classification model, use the natural attribute of the date to classify every day in a year into any of these categories. Then when we do the when we try to design an algorithm to generate the expected value, we can refer the similar days in the same category. So we get some more data. It seems like the data problem has resolved. So we do some very traditional data mining methods, is logistic regression or something to do the expected value generation. And in lots of the days, we found another problem, just like this one. Here is a simple one. In the blue line is the real value, and the green line is the expected value. So we can see the shape or trend of the curve are similar, but we still have lots of the gap. So in such case, if we don't adjust the threshold, we still got lots of the false alarm. So what's the reason? After some analysis, the problem occurs just because I will speed up. So just because the clustering method we used. So we used the CDF. The CDF actually just reflects the shape of the trend, shape of the curve, but not the exact values in the points. So the second idea to deal with these things is we just do the real-time fixing. So what is the real-time fixing? The idea is it looks like this. In the practical, we generate the expected value and get the real value points by points. So before generates the next point's value, these two values, we actually already know the real value and the expected value before these points. And we also can know if the real value are normal or abnormal. So we can base all these knowledges to adjust, to add on some fixing to the next point's expected value generation. In another word, so if some value just before this point are normal, so we can adjust the expected value more likely real value, more near to the real value. But if we already know the real value has been anomaly, has found some bad things, we will adjust our expect value in the real time to make it just a little far away from the real value. So as time limitation, I will skip the formulas explanation. But simply, we use some time window-based method to do the real-time fixing. If the points, real-time points in this window are all of the normal point, we use the first formula. If a part of the becomes normal, we use the second. If all of those are normal, we use the third. And this is experimental result. We also list the previous result here to do the comparison. So in the left picture is our result in this state. I will explain the colors here. So the black color means the real-time value. The green color means the previous very simple method to generate the expected value. And the blue line means blue color means the expected value generated by our new method. So you can see the method is not perfect, but good enough to do the anomaly detection. Okay, so this is a final slide. So this is copied from a real service curve in one of the Baidu services. The time is January 1st this year, the New Year's Day. So you can see our method, the blue line and the black line is almost duplicated here, but the green line is a pretty large gap. So I think the result is looks like very promising. Okay, so that's my talk content. So any questions? Thank you. Can you use mic?
Doesn't making future predictions conditional on past observations and the difference between what you expect and what you observe mean that while you will find a sudden decrease in traffic correctly, you may be masking slight decreases in traffic, so an outage that is small but grows larger and larger as the divergence between your expectations and what's actually going on grows.
So you mean so if the traffic's not the sudden drop, but
if it's
slightly
drops, then that divergence gets larger.
Yeah, it's another kind of anomaly. We use another kind of method. So this method, yes, you are right. This method is not so one for all method, just for the very typical scenarios. So we use in the sudden drop. Just the gap threshold-based anomaly detection measure. Yeah, thank you.
Hi, I'm Manoj from PayPal. So regarding the festival-related thing, right, that you talked about, that in the anomaly detection you take care about the festivals, right, and those are not fixed. So you define them and you feed that in the anomaly detection. But in the real time, how you are handling that? Do you feed any kind of data that in real time these are the festival dates to capture the anomaly?
I'm sorry, but I can't see this or fully understand your question.
So for the detection, right? So you have the festival and you have the fixed pattern of the dates, right? You showed us the chart where you have the Saturday, Sundays, and the festival days. So those are like you determine ahead, right? What are the dates for the festivals? In the real time, how do you do that? In the real time detection.
I'm sorry, maybe we can discuss it offline. So
okay, sure, no problem.
I have some difficulty to understand your question.
Okay.
Sorry.
Hi, thanks for the talk. So just a very general question for folks in the room that might not be as familiar with some of the statistical analysis methods you used against time series. Is there any literature or resources you'd recommend taking a look at to further deep dive into some of these topics?
Actually, it's time sequence processing is a very large area to you can just do some Google search. You'll get lots of the literature on time sequence. But about data mining is not a big area, right?
Cool. So maybe I'll find you after to talk more.
Okay, thank you.
Does your team in any way, based on your forecasting, have different monitoring parameters that you put in for a green day, a blue day, or a black day, so that the teams respond differently, or you use this predictive to change the actual alerting schema?
No, not the different color for different response. So the different color here means the expect value and the real value. We just consider the gap between the different colors. But we will do the different response between the gap size.
Okay.
Sorry.
Thanks.
So that's all we have for questions right now. So let's give one more round of applause.
Okay, thank you.